Let's now design a 4-bit unsigned adder. So assuming that you have two 4-bit numbers, A3, A2, A1, A0, that's basically binary number A, and then you have B3, B2, B1, B0, which is basically B. A0 and B0 are the LSBs of A and B, while A3 and B3 are the MSBs for A and B. Now we want to perform a binary addition on this. How do you build a circuit to do that? So let's do the binary addition here. Now we know that if you do A0 and B0, the sum would be S0 with a carry C1. Then you can have S1. C1 plus A1 plus B1 will give you S1 with a carry C2. C2 plus A2 plus B2 would give you sum S2 with a carry C3. And C3 plus A3 plus B3 would give you sum S3 with carry out. Now typically the carry out is ignored. It can be treated as overflow, but it's up to the designer if the designer wants to include that carry out as your 5th bit. For simplicity, let us assume that carry out is my 5th bit. How do you design a circuit to do this operation? To do this operation, as you can see, we start from the right hand side where we add A0 and B0. You're adding two things or two bits, therefore you can use a half adder. The half adder produces output S0 and C, that's the carry. In the next step, you're adding 3 bits, so you can use a full adder. The full adder produces some S1 and a carry. Then you can add 3 more things using a full adder. So that produces some S2 and carry C3. And finally, you can add the last 3 things or the last 3 bits using a full adder, producing outputs S3 and C out. And the circuit would be as follows. So you have one half adder with inputs A0, B0. It produces output S0. Then you have a full adder with inputs A1, B1. Now the previous half adder produced a carry which was C1. So that's the third input for the full adder. The full adder produces output S1 and a carry. Then you had another full adder with inputs A2, B2, and the third input being the carry out of the previous full adder, which is C2. This full adder produces some S2 and another carry. Then you have the last full adder, which produce with inputs A3, B3, and the third input as the carry from the previous stage produces output S3 and a carry out, which is the 5th bit. And this is a circuit for a 4-bit unsigned adder. This adder is also known as a ripple carry adder. It's a 4-bit ripple carry adder or an RCA. The reason it is called a ripple carry adder because let's go from the right hand side. You have a half adder which produces some S0 and C1, that is a carry. This carry goes to the next stage, that carry goes to the next stage, and that carry goes to the next stage, finally producing a carry out. So the carry is rippled from the right hand side to the left hand side. That's where the name ripple carry comes out.